These notes are for Unit 1, Lesson 8, Converting Fractions, Decimals, and Percents. We'll also do addition, subtraction, multiplication, and division of decimals on the back. So start with the beginning. I'm just going to go over the basically what it looks like when you're converting fractions to decimals to percents, and I'll even give you a little reminder on a way to remember converting between decimals and percents, a simple way to remember. But first of all, I'm just going to fill these in. I'm not going to show you necessarily how they get done yet until we get down to the examples, and I'll show you how they're getting done. I might give you a little explanation of maybe what I'm doing, but we'll get into the actual work part of it in the examples below. But converting a fraction to a decimal, I just divide the numerator, remember the numerator is the top number, by the denominator. That's the bottom number. So that would look like this. Top dog goes in the house. That means the top number goes inside. If I carry that operation out, dividing 3 by 5, I end up with 0.6. Now, 0.6, it's real easy to take that and change it into a percent. All I got to do is take the 0.6 and move the decimal 2 places to the right. There's 1, so I got to add a 0. There's 2. So that gives me 60%. Now, doing the reverse, going from 18% to a decimal, I just take the decimal because whatever whole number you have, the decimal is the first place to the right of the whole number. So right next to the 8, on the right, there's a decimal. To change that into a percent, I move it back to the left. So it would be there. So now my decimal would be 0.18. So the 0.18, and if you think about it, making that into a fraction, maybe not as difficult as you might think. If this is the tens, and this is the hundreds, sorry about that. This ends up being 18 hundredths, or 18 over 100, 18 hundredths. I can reduce that. And remember, I've told a few people this, if if two numbers end in 0, 2, 4, 6, or 8, they can both be reduced by dividing by 2. Well, I have an 8 and a 0. I have an 8 and a 0. Those are in my list there. So those are both divisible by 2. So let's divide them both by 2. 18 divided by 2 is 9. 100 divided by 2 is 50. So I've got an even lower fraction. It's reduced. It's simplified. There's nothing that goes into 9 and 50, so I can't reduce that fraction any farther. Okay, so that's really how you do it. So let's look at what we have here in the examples below. I've got a couple that I've marked out because I don't like them as examples because they have repeating decimals, and I don't really want to get into that part. That's something that's best used for calculators a lot of times. Well, let's stick to the simple stuff first in our examples. We've got this first decimal, 0.08. I'm going to write something over here on the left. Converting, and I'm going to just work right now between decimals and percents. What's the first letter of decimal? D. What's the first letter of percent? P. Which comes first alphabetically, D or P? Well, if you go through, you have a D and then P comes later in the alphabet, right? I don't like that P. I'm going to fix it. P comes later in the alphabet. And this is how I want you to remember this. When converting from a decimal to a percent, you move the decimal 2 to the right. When converting from percent to decimal, you move the decimal 2 to the left. Hopefully that's a little way that'll remind you of how to do this. You're always moving 2 places. Depending on what you're doing, it's either going to the right or to the left. So if you can remember D comes before P, decimal to percent, you got to move the decimal 2 places. Percent to decimal, you got to move the percent 2 places. And that one way is to the right, one way is to the left. So if we start with decimal, we've got to move the decimal 2 places to the right. So that gives me a 0.8, which all I really need is the 8%. So that really 8% means 8 per 100, which again, That's my tens. This is my 100s. So I've got 8 hundredths. So my fraction is 8 hundredths, or 8 per 100, which is also what 8% means. Because you think about it, how many cents in a dollar? 100. Well, 8 over 100, can I reduce that? Yeah. Well, let's look at it that simple way I said earlier. Is there a 0, 2, 4, 6, or an 8 in both of my numbers? Ending in both of my numbers? Yeah, 8 and a 0. So those can both be divided by 2. That gives me 4 over 50. And I look at it again. Is the last number of both of my numbers, is it a 0, a 2, a 4, a 6, or an 8? Yeah. I've got a 4 and a 0, so this can be divided by 2 again. 4 divided by 2 is 2. 50 divided by 2 is 25. Okay, so nothing goes into 2. Well, the only number that goes into 2 is 2, and 2 does not go into 25. So that is my final answer. I'm done there. Okay? So let's just don't get too wrapped up in too many different things. This is really a simple, straight ahead thing that we're doing here. Okay, let's move on to the next example here. We've got 24% over there. Remember, if we're going from percent to decimal, we're going this way, right, on this one? So I need to go left from percent to decimal. I need to go left 2 spaces. So my percent, I go left 2 places. So I'm going to end up with 0.24. You can put a 0 there in front. There's nothing wrong with that. It's not more right. It's not more wrong. It might look a little prettier. It might have been the way you were taught. But that 0 out front doesn't really do anything. Okay, if there's nothing there, it means 0. If the 0's there, it means 0. And again, we have 2 places past the decimal, tens and hundreds. We always go to the last place. So that's 24 hundredths, okay, or 24%. 24% is 24 over 100, or 24 hundredths. Same thing. Do I have a 4 and a 0? Oh, I have a 4 and a 0, so I can divide both of those by 2 if I want. Now, some of you might have jumped ahead, and you already know you can divide those both by 4 easily, but I'm going to go a little bit slower. Now, my last 2 numbers, I got a 2 and a 0. Those are divisible by 2. That gives me 6 over 25. Now, I think about that. I don't have a 0, a 2, a 4, a 6, or an 8 as the last number in the numerator and the denominator. I have a 5 in the denominator, so I can't do anything with that. I can't divide them by 2. So I got to think about, okay, 6. Does 6 go into 25? No, it doesn't. Not evenly. What else makes 6? 3. 2 times 3 makes 6. So 3 goes into 6, but 3 does not go into 25, so I can't use 3. And we already know we can't use 2, and we don't want to use 1, because 1 won't do anything for us. So we're done. Okay. Number 3, if you really want to, I'll fill it in for you. If you divide it, once you divide 7 by 12, you end up with 0.5833, and it keeps on going. The 3 just keeps on going. And we would make that, again, if we're turning a decimal into a percent, I got to move 2%. I got to move it 2 to the right. So that just gives me 58.33, and it keeps going percent. Okay. Number 4, we got to move that decimal because we're going from percent to decimal. So remember, percent to decimal, that means I'm going right to left. So I got to move it left 2 places. So I move it 1. Well, I've only got 1 spot. Do I stop? No. I add a 0. Then that's my 0.045. So this would be 0.045. And you can put the 0 out front if you want. And again, I got tens, hundreds. This is thousands. So I end up with 45 1,000ths. Is that reducible? Yeah, I can. 5 goes into both of those. If I have a 0 or a 5, 5 will go into that number. So if I divide by 5, end up with 9 over 200, and that won't reduce anymore. Okay. Last example I'm going to do for you. We're starting with a 0.7, that's 7/10. That might give something away to you right away. If we say it as 7/10, guess what? 7/10. That's exactly what it is, 7/10. And if you divide 7 by 10, do 7 divided by 10 in the calculator, you get 0.7. Now, to turn that into a percent, I take that and I move it 2 to the right. Well, I only have one place. Well, guess what? I add a 0. Now I have to move it 2 places. Every time you move it 2 places, if you run out of numbers, add a 0 in there. So we get 70%. Okay? Try those other ones on your own. You can skip 6 and 9 for now. Try 7, 8, and 10. I want you to do 7, 8, and 10 after we're done with the notes. So you're going to go back to those. But I'm going to go ahead and go to the back here, because this back's not terribly difficult. Some of it's easy, some of it's hard, but I'm going to look at all these numbers. So really, adding and subtracting decimals, the simplest thing to do is line up the decimals. Add any zeros wherever you need to put zeros as placeholders, and I'll show you how to do that. I'm going to go through, I'm going to do the evens. I want you to go through, and I want you to do the odds. And then I'll show you how to multiply and divide. There's rules up here to follow, but I'll show you what you need to do as we go along. Number 12, we've got 5.29 plus 4.9. So we just write it like that, 5.29, and I need to line up the decimals in my two numbers, 4.9. Okay, add that. Well, I got a weird little space there underneath that 9 in the 5.29, so I just add a 0. It's just a placeholder. It's not adding any numbers. If I add 0 to something, I haven't added anything. If I subtract 0, I'm not subtracting anything. So 9 plus 0 is 9. 9 plus 2 is 11. I carry 1. 5 plus 4 is 9, plus 1 is 10. And I just bring down the decimal. The decimal stays right there. It just comes straight down. Same thing with subtraction. We line up the decimals and subtract. So we got 12.3 minus 6.63. Notice how I lined everything up. I'm subtracting that. Well, now I've got this weird empty space over there next to the 3 in 12.3. I just put a 0 in there. Okay, now it's just regular subtraction, and really, you can bring your decimal down now. It's not moving around when you're adding and subtracting. So when we get to multiplying and dividing, we got to pay attention. 0 minus 3, can't do that, so I got to borrow. So I got a 2 here. Now I've got 10 minus 3, 7. 2 minus 6, can't do that. So now I got a 1. I bring the 1 over, now I've got 12 minus 6, 6. Now I've got a 1 minus 6. Well, I can borrow that 1 and it becomes an 11, or 11 minus 6, which gives me 4. So I got 4.67. That's all there is to it. Multiplication still helps to line up your decimals. Actually, it really doesn't. You don't even have to do that. I would do it like this. Let's do 6.2. And you just want to line up your last numbers. So 2 is my last number in the 6.2. 4 is the last number in 1.4. I just want to line up my last numbers. That's the simplest way to do it. And it's just like long multiplication. 4 times 2, 8. 4 times 6, 24. And I want to keep my columns kind of lined up, right? Kind of like that. So I've got things lined up, but I'm going to take my dots out. Then I got to move over one. So I add a placeholder down here. Every time I move down a line, I need to add another placeholder because everything's going to move over one. 1 times 2 is 2. 1 times 6, 6. Now I can just add those numbers straight down. 8. 4 plus 2 is 6. 2 plus 6 is 8. Am I done? No, because if I think about it, going up there to the top, let's forget anything to the right of the decimal. Let's just look at 6 times 1. Well, 6 times 1, that's 6. So my answer's got to be somewhere around 6, and 868, that ain't it. So I got to look, how many numbers do I have to the right of the decimal in my multiplication up here? Well, I have right here, I got 1, and here I got 2. So I need to have 2 numbers to the right of my decimal in my answer. Well, guess what? Let's start at the end and go 1, 2. There's where my decimal goes. So my answer would be 8.68. That's a lot closer to 6 than 868, right? That makes more sense as an answer. Let's look at number 18. 3 divided by 0.6. Now this is where people get messed up. Remember, we read a sentence left to right and we read paragraphs top to bottom. So if I rewrote this so it looked like a fraction, and the only reason I'm doing this is so it makes it maybe simpler to understand where the numbers go when you actually do the division work, it would be 3 divided by 0.6. Now, the reason I did that is so I can do that top dog goes in the house. Number in the top goes inside. The other number goes outside. Now you might be going, well, how do I do 0.6 into 3? Well, it's not that hard. We're going to move the decimal over 1, so that becomes a whole number. Well, if I did that there, I'm going to have to do it here with the 3. So I'm going to have to add a 0. So now my decimal is there, and I put the decimal directly above where I moved it to. Okay, so now we've basically got, let me rewrite it so it looks real simple. Now we basically have this. That's a lot easier than 0.6 or 3 divided by 0.6. Now we've got 30 divided by 6. That's a lot easier. I'm going to do it on both sides so you can see how it goes. Okay, does 6 go into 3? No, so I don't write anything. Does 6 go into 30? Yeah, 5. 5 times 6 is 30. Subtract that. Sorry about that. That is a 0. Shout out to Michael. Same thing over here. 6 goes into 30 5 times. 5 times 6 is 30. Subtract that. I'm sorry, that's a 0. And that's a 0. So our answer is just 5. If you want, you can put 5.0, but our answer is just 5. Okay? So I want you to work on those examples up on the front. You need to do 7, 8, and 10. If you want to do 6 and 9, have at them. Give them a shot. And I also want you to do the odds on the back. Odd numbers are numbers that cannot be divided by 2 evenly. You will always get a half left over. So 11 divided by 2 is 5.5. 13 divided by 2 is 12.5. 15 divided by 2 is 7.5. That's why it's an odd number. It has something left over, as in after the decimal. Evens are divisible by 2. 12 divided by 2, 6, whole number. 14 divided by 2, 7, whole number. 16 divided by 2, 8, that's a whole number. So that's the difference between evens and odds. I know some of you still don't quite understand that, but that's why I go over it. So again, you're doing the odds on the back, and you're also doing 7, 8, and 10 on the front. You can try 6 and 9. And that is it for this note.